Good evening, students of class 10. Let us now introduce a new topic, potential difference. In the previous video, we have studied how the electric current is passing through a conductor from the topic atomic theory of electricity. Okay. Now, let us consider a short length of a conductor. One end is X and other end is Y. You can see now some electrons which are flowing in random directions inside the conductor. These electrons are called as free electrons. Now, these free electrons will be traveling in different directions, that is random directions. How will you make them to flow all in a single direction? Yes, by connecting the two ends across a battery. Okay, let us connect the two ends. The end X is connected to the positive terminal and the end Y is connected to the negative terminal of a battery. So this is positive terminal, this is negative terminal of a battery. The moment we connect a battery across the conductor, now a potential difference is said to be established across the conductor. So there is a potential difference between the two ends X and Y. The end X is at a positive potential and hence this positive potential is said to be at a higher potential. The end Y is said to be at a negative potential or lower potential. So whenever a potential difference is established, so V is the potential difference across the conductor XY, and the electrons will now start to flow from the end Y towards the end X. So this is the situation. This is the situation taking place inside any conductor. Okay, students. So the moment a potential difference is established, a few quantity of charge is flowing from the lower potential to the higher potential. Now normally you ask a very simple question. Can a stone fall from the top of the building towards the ground by itself, or should we push it downwards? Good. The stone will fall by itself. Why? Because it is traveling from a higher potential to a lower potential. Can you imagine, can you expect a stone to move from the ground to the top of the building by itself? No, it cannot go by itself. So what do? We take the stone in hand and we push it upward. We give some energy. We do some work in pushing the stone in the upward direction. Then it is possible. In a similar way, here a few coulomb of electrons are flowing from a lower potential to the higher potential. So for any flow from a lower potential to the higher potential, what should be done? Work has to be done. Good. So I will take W joule of work is done. So W is the work done. W is the work done, which is expressed in unit of joule. To transfer how many coulomb of charge, say for example Q. Q is the quantity of charge. So Q is the quantity of charge. And charge is expressed in coulomb. Charge is expressed in coulomb. So how much joule of work I have done is W joule. To transfer how much coulomb of charge, that is Q coulomb of charge. So for Q coulomb of charge, W is the work done, means for 1 coulomb of charge, how much work naturally it has to be required, means then it is the fraction. It is the fraction W by Q. So this W by Q is the work done per unit charge. So work done per unit charge. So unit charge means 1 coulomb. For Q coulomb, W joule work is done. Therefore, for 1 coulomb of charge to travel from the lower to higher potential, the fraction W by Q has to be done. This work done per unit charge only is called as the potential difference. This is the definition for potential difference. So this only is equal to V. So therefore, V is equal to W by Q. The unit of W is joule. The unit of Q is coulomb. So what should be the unit of V? It must be joule per coulomb. So I will write joule per coulomb. And is there any other unit for potential difference? Yes, We have heard already, it is volt. Therefore, joule per coulomb also is called as volt. So we have got another definition from this expression. Yes, we are going to define 1 volt. We got the definition for 1 volt from this expression. Suppose you take 1 coulomb of charge is transferred from this lower potential to the higher potential. That is, if Q is equal to 1 coulomb, okay, and in this process, suppose 1 joule of work is done, then what should be the value of V? Yes, your guess is correct. Therefore, what is V equal to? That is 1 divided by 1, that is equal to 1 volt. So this is 1 joule divided by 1 coulomb, which is also equal to 1 volt. So let us summarize this small topic, students. 2 definitions we have learned. How will you define potential difference across a conductor? Potential difference across a conductor is defined as the work done per unit charge. What is its unit? Its unit is joule per coulomb or volt. The second definition we have learned today is 1 volt. 1 volt is said to be the potential difference between any 2 points of a conductor when 1 joule of work is done in moving 1 coulomb of charge between the 2 points. Okay, students, have you all understood? Good. Now we are going to solve some numerical problems based on this concept and the definition of electric current. Until then, wait. Yes, now we are going to solve 2 numerical problems. First one is example 12.1 in your textbook. It is given in page number 200. If you have the textbook, means you can refer to the textbook. I will read the numerical problem. A current of 0.5 ampere is drawn by a filament of a bulb for 10 minutes. Find the amount of charge that flows through the circuit. First, whenever you read any numerical problem, patiently you should go through the problem twice and write all the informations or data given in the problem. How much data are given? Let us see now. So what is the given information? I will make a list. So what is the current flowing through the filament of the bulb? Yes, 0.5 ampere. So the symbol for current is I. I is equal to 0.5 ampere. Then for how much time the current is flowing is 10 minutes. So I will write T. T is equal to 10 minutes. But minute is not the standard unit of time. The SI unit of time is seconds. So 1 minute is how many seconds we must know? It is 60 seconds. Therefore, what is 10 minutes equal to? So this is now equal to what? 10 into 60. So this is equal to 600 seconds. So the time is 600 seconds. Now what is asked in the question also we must write here. So Q, the quantity of charge flowing through the filament, is asked. Yes, sir. Can you tell me the relationship connecting the 3 quantities I, Q and T? Beautiful. Yes, yesterday only we have seen. So current is defined as the rate of flow of charges. So I must be equal to what? Q by T. So I will write I is equal to Q by T. So which quantity we have to find here? Q. So this equation implies Q is equal to what? I into T. So this implies what? Q is equal to I into T. So what is the value of I has to be substituted? 0.5 ampere. So this is equal to what? 0.5 ampere into the time taken is how much? 600 seconds. So this is equal to 600 seconds. So the product is now equal to what? This 0.5 into 1 0 will cancel. This will become what? 5. So 5 into 60. So this is equal to 300 coulomb. 300 coulomb. Yes, how many of you have understood? Yes? Beautiful. Yes, sir. I hope. Any doubt? Shall I proceed? That's well. This is one problem, numerical problem based on the definition of electric current. Now, another problem we are going to do based on the potential difference which we have seen just now. Okay, students. This is a question, problem number 12.2. It is given in page number 202. You can open the textbook and read the problem carefully. I will also read along with you. How much work is done in moving a charge of 2 coulomb across 2 points having a potential difference of 12 volt. So there is a conductor, and between any 2 points of the conductor the potential difference given is how much? Yes, 12 volt. Okay. How much coulomb of charge is flowing through the conductor is given? 2 coulomb. Did you all carefully read the problem? Yes. What I said, whenever you want to solve any numerical problem, yes, we have to write the data. Okay. Whatever is given we will write. So what are the quantities given in the problem? Anyone of you tell me what is the quantity of a charge flowing through the conductor? You tell me. Yes, it is 2 coulomb. So what is the symbol for it? Q. That's good. So Q is equal to 2 coulomb. One of you tell me what is the symbol for potential difference? Yeah, it is V. So it is given V. V equal to how much volt is given? 12 volt. What is asked here? What we have to find? How much work is done? What is the symbol of work done? Yeah, W. So W is questioned. Just now we defined the potential difference between 2 points is the work done per unit charge. So what must be the relationship connecting all the 3 quantities? You are right. W by Q is equal to V. Okay, I will write W by Q. This is what? Yes, work done per unit charge. This only is equal to V. Now, what we have to find is W. So, this equation implies that W is equal to what? V into Q. Very simple. It's a product of just 2 numbers. Easy numbers they have given. Yes, your answer is correct. Your guess is correct. Wait, please wait. So, therefore, W is now equal to V. The potential difference is what? 12 volt. Okay, so this is 12 into the charge is how much? 2 coulomb. So this is 2. For this you need not wait for a calculator. Nothing is required. 12 2s are what? 24. Just you should know the multiples of or tables of 12. That's all. So 12 2s are how much? 24. Your answer is also correct. All are correct. Okay. So 24. But what is the unit? Yes, sir. You can say joule. Yes, joule only. Very good. Your answer is correct. Yes. So this is how we have to solve the numerical problem. For competitive exams, so the very fundamental has to be learned. The very fundamental is without knowing the concepts, you don't by heart, please. Okay. Well, now after this, I will just take another new topic. Before that, we will go through the symbolic representation of the electrical quantities after this. Have you understood? Shall I erase the board? Okay, done. Now we are going to discuss some symbols used in electrical circuits. In electricity, whenever we draw the circuit, the actual electrical components we cannot draw. That is why some shortcut symbols are permitted. So, we will introduce some electrical symbols used in electric circuits. The first one is having a positive terminal and a negative terminal, which is represented respectively by a longer line and a shorter line. This we have already used. That's good. It is a cell. So this is a cell. Now in the second picture, how many cells are joined? You see 3 cells. Okay. Such a combination of cells is called as a battery. So the second one is called a battery. The third one, which is having a bracket symbol, is called a switch or a plug key. It is just like a plug and a socket. Just like the 2-pin plug is having 2 pins and 3-pin plug is having 3 pins. This is a single pin opening and it is called as a plug key. Plug key or switch. This also can be called as a switch. But this plug is not inserted, means the key is open. So this will not send the current. So it is kept in open. Now the same key, when the plug is inserted, what will happen? There will be contact between these two terminals and current will start to flow. So the same, this also is called as what? A plug key or switch. But this time this switch is closed. This is a closed switch. Now in electrical circuits we can see so many wires will be meeting at one point, that is called as a junction. And this is also called as wire joint. You can see that one wire is joined with the other wire. So this is called as a wire joint. Are you all able to see the board? Is it readable? Is it clear? Good. So this one is a wire joint. And sometimes one wire may overlap with another wire, which may lead to short circuit. So to avoid that, there are some proper insulations required for the wires. Now you can see that two insulated wires are crossing over one another. So this one is called as the wire crossing. So wire crossing. Whenever two wires are crossing one over the other, there should be a proper insulation. That is very important. Now the seventh one is very simple. This is looking like a filament. So where will be the filament found? Is the filament found in a fan? No. Good. Where it is found? That is in a bulb. Okay. This is a filament bulb. So this is an electric bulb or a filament bulb. Okay. This one is looking like a speed breaker. Is it not? In the road we are seeing like speed breakers, like zebra cross. Yes, you are right. Yes, this is the symbol for electrical resistance. So it is putting some block for the flow of electric charges. So when the resistance increases, what will happen to the current naturally? It will be reduced. That is right. So this is electrical resistance. Now in some electrical circuits, the resistance of the wire or the resistance of the circuit will not be constant. Sometimes you will have to increase, sometimes you will have to decrease. So we need a variable resistance. That is given in the next symbol, that is 9. A very simple difference only between the resistance and the second one. This is also a resistance which can be varied. It can be lowered or increased also. So this is a variable resistance. Next picture, you see that here also there is an arrow. Instead of crossing over the resistance, it is kept over its head. What is this called as? Do you know? It's a very peculiar device that is called as a rheostat. You can see that this arrow mark is a sliding portion. It is a metallic contact. It is a metallic contact which can move from one end of the resistance towards the other end. Between the two ends, you can locate the position of the slider. And you can vary the resistance here also. Here also you can vary. But one difference is there between the variable resistance and the rheostat. See, all rheostats are called as variable resistances, whereas all variable resistances cannot be called as rheostats. Can I give one simple example? Have you ever seen the fan regulator? Yes. Can you adjust the speed of the fan? You know that when the fan regulator is kept in number 1 means speed is less, and when it is adjusted in position number 5 means the speed is more. What is happening actually? These numbers 1 to 5. If you open that regulator and see, there will be a potentiometer which is nothing but a variable resistance only, and that is not called as a rheostat, because for every one fixed position the resistance will be fixed. So it is having 5 different value of resistances which can be varied. Now this device A, in electrical terminology, A for ammeter. Yesterday only we have seen A represents an ammeter. Yes, you tell me, what is the use of an ammeter? Yes, to measure which quantity? Electric current. That's good. So this one is what? Ammeter. And the next one, the instrument which is used to measure the potential difference across the conductor, and that is denoted by capital V. So V is the potential difference. The potential difference can be measured by what instrument is called as voltmeter. So this one is voltmeter. meter. And a very important information about the ampere meter and the voltmeter I will tell you now itself. Whenever you want to measure current in a circuit, ampere meter is to be connected. But how you will connect the ammeter means the ammeter is always connected in series to the device through which the current has to be measured. Similarly, how to connect the voltmeter is very important. Suppose if you want to measure the potential difference between 2 points of a conductor, you have to connect the voltmeter in parallel. Lastly, this is not given in that page where the symbols are given in the textbook, but very important. This one is called the galvanometer. This is called as the galvanometer. So, galvanometer is an instrument which is used to just check whether current is flowing in a circuit or not. That is used to detect the current in a circuit, and you cannot use this galvanometer to measure the current in a circuit. Understood, students? Galvanometer is a device, what for it is used? Just to detect whether current is flowing or not. But at the later stage you are going to study that the galvanometer can be converted into an ammeter as well as voltmeter. Understood, students? So all these symbols you must learn thoroughly, because we are going from the next topic, higher level, we are going into electricity. So everywhere we should use these components of electricity only. So all the symbols you have to write today itself and practice. You draw the symbols twice and write the names also twice. You will be thorough. Okay, students? Have you all noted down all the symbols now itself? That's good. Shall I raise the board? Good.